Hello everyone. So we continue our solutions and we are at problem 14 of the practice exam. So one amplifier produces a sound that is 90 decibels. So we have the decibels level is equal to 90. What would decibel reading six amplifiers producing the same sound in the same location produce? Okay, so the way to solve this problem is to use two formulas basically. So we have relative intensity is equal to 1.26 raised to the power decibel. And the inverse of this formula is that the decibel is equal to 10 multiplied by log of relative intensity. So when we have 6 amplifiers, basically what we are multiplying by 6 is not the decibel value. We're multiplying by 6 the relative intensity. So this is the initial relative intensity. The new relative intensity that's equal to 6 times 1.26 raised to the power decibel, which is basically 90. So that's the new relative intensity. Now I have to use, I want the new decibel reading. The new decibel reading that's equal to, I'm gonna use now this formula. Okay, this is my formula. So the new decibel reading that's equal to 10, and you have to really be very careful. 10 multiplied by log of 6 multiplied by 1.26 power 90. So now to calculate this, I have (1.26) to the power, or the power again, I forgot, 90 that's a huge number, multiplied by 6, another huge number, log of this number. See how compressed it becomes? It becomes 9.8. So, and then multiplied by 10. So that's 9.8 multiplied by 10. That's 98. Wow, that was a huge number. And when we found the log of that number, it became 9.8. Pretty neat. So the answer is 98 decibels. So again, we multiplied the intensity by 6 times, but the decibel increased from 90 to 98. See again why the decibel representation is a very compact, compressed representation. Moving on to 15. Let me make sure I have my blue pen. Okay, so solve 100 multiplied by 0.96 power x is equal to 25. Then select the correct choice below. Basically they want to know what solution is negative or what's basically the value of my solution. So solve meaning to find x. To find x, I see I have an exponent in the I I have an unknown in the exponent. So the way I do it, I go here, 0.96 raised to the power x is equal to 25 divided by 100, and that's 0.25. So let me zoom in a little bit. So 0.96 power x is equal to 0.25. And this reminds me of a very famous formula. So a power t is equal to b. This means the solution x is equal to log. Let me make sure I got the relation right. This is from page 187. So a is equal, the formula says a is equal to b power x. So x is log a divided by log b. So this is my a, this is my b. So x is equal to log 0.25 divided by log 0.96. Okay, calculator. Log, notice it's a negative number, divided by 0.96 log, and the answer is 33.9. I hope I didn't do any mistake. So the answer is 33.9. That's my answer. Solution is greater than 30. Okay, 0.25 doesn't make sense. So I am definitely dividing a small number by a bigger number and the log of them. So it seems to make sense. Let me do it again. Log 0.25 divided by log 0.96. Divided by 0.96 log 33.9. Okay. So that's my answer, and we move on. And my favorite, tables. Oh, I love tables. Okay, is the data in each table linear, exponential, or neither? Okay, let me because now you guys can pause and look back at the problem. Let me clean it up a little bit. Okay, is the data in each table linear, exponential, or neither? If the data is linear or exponential, give an equation for the data. Whoa, that's a deep. So in case it's linear, you have to give the equation, which is y is equal to mx plus b. So you have to find m, you have to find b. If it's exponential, y will be equal to some number initial y multiplied by base to the power x. So that would be an involved. So what's the quickest way to know if it's linear or not? Look at the difference between y1, y2, y2, y3, y3, y4. So you notice that 3.6 divided by 1.8. So 3.6 divided by 1.8 is 2. Or I can say 3.6 minus 1.8, that's 1.8. So that's the difference. So the difference will be, so it's like I multiply by 2. Now from 3.6 to 7.2, again I multiply by 2. So it's probably an exponential variation. So 7.2 divided by 3.6, that's equal to 2. 14.4 divided by 7.2 is equal to 2 also. Now you might ask me, why did you say that it's not, how did you know that it's not linear to begin with? And in order to test for a linear function, I simply subtract the first number minus the second number. So let me write this down. Testing linear functions. So how did I arrive at the conclusion that it's not linear? So I did 3.6 minus 1.8, that's 1.8. Now then I said 7.2 minus 3.6, and that's 3.6. Whoa, so I noticed that the difference is not the same. Same thing, 14.4 minus 7.2, that's 7.2. So it's not the same difference from year to year, from x to x, so I know it's definitely not a linear. And then how to test for exponential variation? You basically divide them as we did before, and I noticed that I'm always multiplying by 2. So this is an exponential variation, and of course I should check that this is also multiplied by 2. So this is exponential variation, and my base is 2. I'm always multiplying by the same base, and y is equal to y0, which is this guy here, 1.8 multiplied by 2 raised to the power x. And I can always confirm. I can substitute, instead of x I can put 1. Y would be equal to 1.8 multiplied by 2, that's 36. I can substitute by x, for example, 4. Y is equal to 1.8 multiplied by 2 raised to the power 4, and that should give me 28.8. Make sense? Well, you can't answer me, but you can always email me if it doesn't make sense. Okay, so another one, x, I have y, so I have some variation. So first I test for linear functions. I evaluate 2.9 minus 1.8, that's 1.1. So this is the variation. Now 4.2 minus 2.9, that's equal to 4.2 minus 2.9, that's equal to 1.3. Interesting. 1.3. Now 5.7 minus 4.2, that's equal to 1.5. Oops. See, it's not the same variation. So it's definitely not a linear function. And I don't have to continue. It's very obvious that once the rule is broken once, it's not a linear function anymore. So it's not a linear function. Now, is it an exponential function? How can I check? I have to divide each two consecutive numbers. So 2.9 divided by, divided by 1.8. So 2.9 divided by 1.8, 1.61. So same thing, 4.2 divided by 2.9, 4.2 divided by 2.9, 1.44. So it's not an exponential function because when I move from here to here, it's not the same multiplier and it's not the same addition. So it's neither not a linear, not an exponential function. So this actually question is involved. It requires more calculations, but it's fun. At least for me, it's fun. Okay. Okay. So now, same thing. Check for linearity. 2.4 minus 1.8. That's equal to 0.6. Same thing. From here to here. 3.6 minus 3, that's 0.6. Same thing from here to here. 2.4. Sorry. 3 minus 2.4, that's 0.6. Same thing from here to here. 4.2 minus 3.6, that's 0.6. So it's a linear function, and you notice that from when I move a unit in the x direction, I move 0.6 in the y direction. What do we call this? We call this a slope. So slope is 0.6. Initial value is this guy, 1.8. If you remember, this is my m, this is my b. So y is equal to mx plus b, that's 0.6, x plus 1.8. If you don't know why the slope is 0.6, which is my variation, it's okay. You can always find the slope in a different way. The slope is the change in y divided by change in x. The change in y, take any two numbers. 3.6 minus 3. So 3.6 minus 3.0 divided by change in x, which is 1. Or 3 minus 2, that's 1. That's 0.6 divided by 1, that's 0.6. So that's my slope, and my b is initial value, which is 1.8. This is my answer. So y is equal to 0.6 x plus 1.8, and it is a linear function, as we said. Okay, so we are left with few problems. I'll make one more video for the remaining problems. You guys take care and have fun.